Okay. The idea of the tyranny of the rocket equation is, here's your little rocket. Yes?
Yeah.
It has some weight, right?
Oh, it's just like the weight changes.
I'm going to say it's got a mass m, right?
Yeah.
For me to think about, okay, here's the world, here's where I want the rocket to be, there's some force of gravity acting on this thing, right? You guys see that?
Where's the road?
I want to get this rocket from, here to there.
Okay.
There's some work to do that, right? I'd have to add up the work and I'd get some number, right? Work, capital W, that needs to happen. Jet fuel supplies some energy, right? That energy is going to come in the form of work, so I can burn jet fuel to make up this W. You all see that?
Yeah.
So I'm going to think here, this is like F fuels, right? The problem is that your fuel, you can't just blow it all up on the ground underneath your rocket and release all the energy at once. Because if you do, the rocket's not going to make it anywhere except into tiny little pieces. You guys see that? Like, here's your blob of fuel. You can't burn it all here. You have to bring some of it higher. You guys see that? So I have like some little bit of fuel here, some little bit here, some little bit here, some little bit here, a little less, right? Unfortunately, for me to bring that fuel up here, there's some work required, right? So I get all these like, okay, there's a little work for this one, and a little work for this one, and a little work for this one, and a little work for that one.
Why not just add up all the mass and just put it on the rocket so you only have to do it once?
You can't.
What?
Because this fuel, right, I had to work to get it up there, so that's going to give some more fuel, but it can't all be burned at the bottom. It has to be burned over the course of the distance. You guys see that? I have some geometric sum here going on that I have to fiddle with. You can escape this with a line integral. But otherwise you have to spend a bunch of time doing summation notation and then put a little extra on at the end to hope. Right? Which is really kind of not the thing you want. So the tyranny of the rocket equation is that to get out of the atmosphere, you need fuel. You have to lift the fuel to get out, right? So you have to burn fuel to lift fuel. But you have to burn fuel to lift that fuel to lift the other fuel and so forth all the way down, right? Until you're sitting on this little column of fuel.
Yeah. I actually did something like that for our E6 class. We had to design a trebuchet out of cardboard tubes. And I used a Fibonacci sequence so it increased the torque as the rubber band lost its distance, and it worked quite well.
Yeah, that's awesome.
It came out pretty neat too.
What's the difference between a rocket, like an object launched with a fuel source like this, and an object launched from a trebuchet?
Well, you get the change in force.
Yeah, so all that change, right? That tyranny, that changing change is happening at the bottom on the trebuchet, right?
Yeah,
It's all
at
happening
one
on the
tangent
ground.
point.
Once it lets go of the object, right? That object has no more fuel requirements. You guys see that? So you have to do this thing in a different place, right? But it's the same thing, yeah. Cool?